Physics, Chapter 22, Coulomb's Law. So this is a continuation of the earlier lessons, electricity. So far we have learned how the electric field would be generated and what electric field strength is. So electric field is a field of force and we can represent it by field lines. The field lines will depend on what kind of, how the electricity is present in that point, whether it is a point charge or whether it is a circular globe, etc. It depends, right? Then electric field strength at a point is the force per unit positive charge that acts on a stationary charge. That is also something that we learned. Then from that we got the equation field strength E is equal to force upon charge, that is F upon Q. Then also we learned that there is a uniform field between charge parallel plates. I suppose you can remember them. So if there are two plates like this, then it would have uniform field lines like this, right? So that is also something that you have to remember and bring back to your memory. Then we got another equation for that. Field strength is equal to potential difference divided by separation, E equals V upon D. And that negative sign scenario also something that you need to understand. That is from the earlier chapter. Then we are going to understand here how electric fields would arise from the electric charges, right? And then we have to make comparisons where necessary for us to understand it better on how electric fields are different or similar to gravitational fields. So the Coulomb's law, the definition of Coulomb's law is that any 2-point charges exert an electrical force on each other that is proportional to the product of their charges. So it is proportional to the product of their charges, right? So the electrical force that is generated on each other is proportional to the product of their charges and inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them. So that is what Coulomb's law states. So based on that, let's see how other phenomena can be described with this. We know that any electrically charged object will produce a electric field in the space around it, right? So it is not exactly it doesn't have to be on a plane. So it is in all the dimensions it would produce. Then this electrically charged object could be a single proton or could be a single electron or could be as massive as a large planet or a star, right? So then when we say that it has an electric field, so that means that it has a force on any other charged object in its vicinity or in its field. So how are we going to figure out such the value of these things, and how are we going to understand what these forces are and how they are created, right? So this was the basic question that Charles Coulomb was trying to answer, right? Then he is the one who brought forward the theory that charges, if considered as point charges, then we can base that principle to explain other theories, right? So this law is quite similar to that of Newton's law of gravitation. So that means this gravitation and electric field, gravitational field and electric field have very common basis behind it. So if we consider 2-point charges Q1 and Q2, separated by a distance r, then we know that the Coulomb's law say that it is proportional to the product of their charges, that is q1 into q2, right? The force is proportional to q1 into q2. Then it is inversely proportional to the square of the distance between them. So that is r square, 1 upon r square, right? So Coulomb's law say that F is proportional to q1 into q2 and F is proportional to 1 upon r square. So these two relationships are developed from Coulomb's law. Then from this we can take, because both are proportional to force, we can say force is proportional to q1 into q2 upon r square. Then we can equate it by putting a constant. K is going to be the constant of proportionality, right? So the constant of proportionality is given by K equals 1 upon 4 pi epsilon O, right? Epsilon O is the permittivity of free space, permittivity of free space, which is given by the epsilon. The epsilon O is 8.85 into 10 to the power minus 12 Fm minus 1, right? Then this from this equation we can obtain q1 upon q2, F equals q1 upon q2 divided by 4 pi epsilon O r squared. You know the value for epsilon O. So we have the equation for Coulomb, for the Coulomb's law. F is going to be the force, q1 and q2 are the charges. 4 pi epsilon O, we have the value for that, 8.85 into 10 to the power minus 12 Fm minus 1. Then r squared is the square of the separation. So this is the law, this is the equation for Coulomb's law. Then this relationship is quite similar to that of Newton's law of gravitation. The force will depend on the properties of the factors, that is, in this particular case it is the charges, right? And we say that it is an inverse square law with the distance. If the particles are twice as far apart, it is quarter of the previous value, because it is the square that we take, right? So in the first instance here, you can see that the force is q1 and q2, then there is F. When they are separated twice as far apart, then because it is inverse square law, then twice means 2 gets squared, that is 1 upon 4F. I hope that makes sense to you. So the doubling the separation results in 1/4 of the force, right? So that is the inverse square law result. Then if we have a positive and a negative charge, then the force is going to be negative because it is going to be an attraction. If they are positive forces, they are repulsive. But in gravity, we only have attraction. Why? That is a difference between electric field and the gravitational field. Because in gravity, it is the attraction. It is we don't talk about a repulsion. So in this situation, we have discussed only the point charges. If we discuss uniformly charged spheres, then we have to take the distance from one of the from center of one of the spheres to the center of the other. Now if we take the moon and the earth, then we have to take from the center of the distance needs to be taken from the center of the earth and center of the moon, assuming that the field, it is a point charge at the center, right? They behave as if, just like gravity, it behaves as if the charges are all concentrated at the center, right? Whether it is a point charge or uniformly charged spheres, we can use Coulomb's law in the same manner, right? Center to center distance between the objects is what we consider. I hope you understood. Before we move on to the practical activity, let's write down a note on this. Write down Coulomb electric fields. So this is a summary of what we have learned earlier. Electric field is a field of force that can be represented by field lines. And when a unit positive charge is placed in it, the force that acts on it is the electric field strength. Right, so the equations I'm not going to repeat because those are the same ones that we discussed earlier. Then write down. Charles Coulomb developed Coulomb's law by considering point charges. Then leave a line and write Coulomb's law states that any 2 point charges exert an electrical force on each other that is proportional to the product of their charges and inversely proportional to the square of the distance between them. Please draw this. This one. And after that you have to write down that relationship using the equations and the proportionality sign. So force is proportional to product of charges. F is proportional to Q1, Q2. Then force is inversely proportional to separation squared. That is, force is proportional to 1 upon distance squared, which is F is proportional to 1 upon R squared. By combining F is proportional to Q1 upon Q2 divided by R squared, we equate that to F equals KQ1 Q2 upon R squared, where K is the constant of proportionality and K has an equation 1 upon 4 pi epsilon O. This is something that we have learned earlier. Epsilon O within brackets permittivity of free space equals 8.85 into 10 to the power minus 12 Fm minus 1. Therefore, leave a line and write, therefore, Coulomb's law has the following equation. And write this one. F equals Q1 Q2 divided by 4 pi epsilon O R squared. Then pause the video and draw figure 22.3. And write down, when the separation is doubled because of the inverse square law, the force becomes 1/4 of the original. Leave a line and write. When we consider positive and negative charges, the resulting force F is negative, meaning that they attract. Positive forces repel. This is a difference between electrical fields and gravitational fields, because in gravitational fields we consider only attractions. Leave a line and write. Coulomb's law can be applied to point charges as well as uniformly charged spheres, because the spheres act as if their charge is all concentrated at the center. However, the distance is considered from center to center. I hope you understood all of this. If you have any questions, you can ask them. If you we will deal with the practical activity and the rest of the lesson in the next video.